Assalamu alaikum. This is Sadia Saeed from Air University, Islamabad. Today, I will be giving you a presentation on the simulations of voltage sensor, current sensor, gas sensor, as well as RTC and SD card with the Arduino. So we shall start with our presentation. We are using Arduino Mega 2560. For the safety of the microcontroller, we are using an optocoupler which is acting as a switch. Basically, in an optocoupler, the electrical signal is transmitted using LED that emits infrared light, which is then paired with the photosensitive device which detects light from the LED. We move on to the function of optocoupler. These are two electrically disconnected circuits. The phenomenon of the optocoupler is that it connects two electrically disconnected circuits in such a way that it transmits signal from one side of the circuit to the other through light. The function of these circuits is mutual, which means that if the left side of the circuit is non-operational, the right side will not be working as well. Now, let's move on towards the inputs of the sensor. We have provided input to all the sensors through pin 13. Here, we have used a relay between the Arduino and the sensors. Actually, this relay works as a current controller to ensure the safety of the sensors. When coding the Arduino, we have to add this condition that whenever the current exceeds the limit of 5 amps, the relay will turn off and break the circuit, thus preventing the overloading of current. Both optocoupler and relay are working as a switch. Then, what is the difference between them? The difference is that relay can tolerate high current, while the optocoupler cannot. The advantage of optocoupler over relay is that it is faster and long-lasting. You must be thinking, why optocoupler is long-lasting? The answer to this is, there is no mechanically work done in optocoupler, while the relay is operated mechanically. In front of the relay, a motor encoder is attached, which is then further linked with a pulse counter, which gives us pulse per second. The pulse counter is then connected with an oscilloscope, which will generate a waveform, thus giving us the pulse rate. Here, we have a variable current load and a variable voltage load. By altering the load, we can change the current of the circuit and observe how overloading of current is avoided by the use of relay. Here on the screen you can see a voltage sensor. Voltage sensor works on the principle of voltage divider. Here, Zener diode is used for voltage regulation. In addition, a capacitor is incorporated for smoothing purposes. The output is taken by an analog pin A0. Moving on, we have a current sensor. In this, we have inculcated a capacitor for the eradication of noise. There are 3 pins for output: VCC, ground pin and the output analog pin. The output is taken by the analog pin A2 of the Arduino. Proceeding to the SD card, the CS pin is connected with the pin 10. Usually on the Arduino boards, the pin 10 is by default set for CS. Now, come towards the file reading of SD card. The software used for this purpose is Notepad++. For opening the file, we will drag this and drop it on the window of Notepad++. Now you can view the values of current and voltage on the screen during varying time intervals. Now come to the RTC. We can either calibrate the time of RTC according to our PC, or we can initialize it by ourselves during porting. As you can see that I have calibrated my time according to my PC. Before advancing towards the code, we will run the simulation. Firstly, the SD card will read the old data on the serial monitor, and then it will read the new data. Moving on to the code. To run the code, you have to make sure that the libraries are included. We have created an object of RTC. Then we have created a file. All the pins we connected to Arduino are being declared. Some variables are also initialized here for future use. There are two main functions in the coding of Arduino. The first one is setup and the second one is loop. Everything that is coded in setup function will only run once, while everything that is coded in loop function will run continuously. In the setup, we have first initialized the serial communication using begin function. The argument we have given in this function is the speed of the serial communication between the board and the serial monitor. Now we will call this function, which will read the format data of the file. We can also see its definition. By using if condition, we will check whether the SD card is initialized or not. If the SD card is not initialized, it would return to the setup. This begin function takes chip select as argument. As it is a Boolean function, so if chip select is initialized, it would return true. Now we will open the file. In this function, we can have two arguments, file path and mode. It is necessary to give file path. However, mode is optional. It can either be file read or file write. If mode is not selected, then the default mode file read is employed. As we want to read the file, that's why we have not selected the mode. Then here we have inserted a while loop, which employs the condition that loop will keep reading until there is something available for reading and printing it on the serial monitor. When all the data will be printed, making the file empty, it will return to the setup function. Then we are calling another function, RTC. It will check whether the RTC is running. We are calling another function, RTC int. It will check whether the RTC is running properly or not. Coming here, you can see the pins with which we are taking inputs are set as input, and same is the case for output pin. Let's proceed towards the loop function. This loop function will run continuously and will repeat again after it ends. Now we will call RTC up, which will give us current time. Let's discuss the body of this function. Here we have created an object now. As aforementioned, we have already calibrated the RTC time according to the PC time. Here we have printed all the times. This DEC is used to convert the time in decimal figures. Here the condition which I have already explained is added, that if the current exceeds the limit of 5 amps, the serial monitor will display the message of overloading. By using this delay function, we will delay our serial monitor for some nanoseconds. The argument given here is in nanoseconds. Now we will read the value from the voltage sensor. For this purpose, we will use analog read because we have used analog pen. The value of voltage we get from here is in 10 bits. We have to map it between 0 to 20. For this we can use map function, but here I have used self-defined function called map float. Going towards the arguments of this function, the first argument we have given in is its original value. The second argument we will give is the range in which the original value lies. The third argument is the range in which we want to map the value of voltage. Here, the low limit I am giving is 0 and the upper limit is 20. The value of voltage returned by the function is printed. Advancing towards the value of current. For printing the value of current, we are using a function get DC current. Two arguments are given to the function. First one is the pin and the second one is the integer. The function will read the current with the help of the pin through a formula and get us the value of the current. Mostly, we do not get a stable value for current, so we take an average. Here, we are not using an average as our value of current is stable. This simplified formula gives us the value of current, which will be printed in the code. After this, we will reopen the file. This time, as we have found the values, so we are ready to write them. Hence, with the file path, we will also use the argument of file write. Here is a condition which will determine whether the file is open or not. If it is open, then it will return us true. To write the values in the file, we will use a function print from my file. The argument given to the print function is actually what we want to print. Then we will close the file. Guys, now I am coming to the elaboration of my gas sensor. The specific gas sensor I am using is MQ6. Before explaining its simulation, I will first discuss its features. Its main feature is it includes its voltages. The operating voltage is 5 volts and the range of analog and digital voltages are 0 to 5 volts. In this picture, I am showing you all the pins of the MQ gas sensor. You can see these pins with their respective labelings on your screen. Advancing towards the pin configuration, there are 4 pins: VCC, ground, digital output and analog output. You can read their descriptions as well. MQ6 has wide-ranging applications. Some of its salient applications are listed here. This is the 2D model of the MQ sensor with 2 different configurations. Now let me show you the datasheet of the MQ sensor. These are the features and applications as discussed earlier. Proceeding to the specifications, These are the standard work conditions of our gas sensor. These are the appropriate environmental conditions in which the gas sensor works suitably. And then the basic sensitivity characteristics are mentioned here. Now I am going to tell you about its structure and configuration. As you can see in the table that various parts of the gas sensors are listed with their corresponding material with which they are manufactured. One of its significant properties is the sensitivity curve. The typical sensitivity characteristic curves of MQ for several gases are shown. Okay, so we have another graph here. It displays the typical dependence of MQ6 on temperature and humidity. Now, here the parameters for sensitivity adjustment are being explained. For varying kinds and concentrations of gas, the resistance value of MQ6 is different. In air, it is recommended to calibrate the detector for 1000 ppm of LPG concentration and use the load resistance of about 20 kilo ohm. Proper alarm time should be determined for it, keeping in view the weather condition. I am opening the simulation now. Starting with the Arduino, this is like the brain of our system. Here is a display screen which will display a message whenever the gas is switched on. This is MQ gas sensor. This is input toggle. Whenever an input is provided, a message is displayed on the screen. Before going to the code, let's run the simulation. As the toggle is off, so it is displaying no gas. As we on the gas supply, the message on the screen changes. For code, we are using a software Arduino IDE. First of all, we have to include all the libraries. Then pins and variables are declared. This is setup function. And this is loop function highlighted on the screen. In this loop function, we have added a if-else condition. When the gas value is 1, we will print oxygen supply on, as we are detecting the oxygen supply. In else, our gas value is 0 and it will show no gas. With this, I am ending my presentation. Hope you all understood it conveniently. Kindly fill my Google form from the link in the description below.